And this video is going to go over the zeros of polynomial functions. Alright. Have you ever heard of the phrase, mind your P's and Q's? Well, I'm going to teach you how that ties into algebra. If P is the constant term at the end, and Q is your leading coefficient, then if you take all your factors of P divide it by all your possible factors of Q, that would give you all possible rational zeros of our function. So using this example, consider this polynomial 6x to the 4th plus 7x to the 3rd minus 12x squared minus 3x plus 2. First part says list all possible rational zeros. For part A, we take all the possible factors of our constant, which is 2, divide by all the factors of our leading coefficient, would be 6. Now the factors of 2 are positive or negative 1 and positive or negative 2. Factors of 6 are positive or negative 1, positive or negative 2, positive or negative 3, and also positive or negative 6. So when we divide these, we would have positive or negative 1 over 1, which would be positive or negative 1. Then our other factor of 2, which is positive or negative 2. 2 divided by 1 is 2. Now we move on to the second factor of 6, which was 2. The first factor of 2, which was 1, divide 1 by 2, so that'd be positive or negative 1/2. And then take the second factor of 2, which is 2. And the second factor of 6, which we had listed as 2. 2 divided by 2 is 1, which we already have, so we can move on to the third factor of 6, which was 3, I think. So, positive or negative 1 divided by positive or negative 3, which would be positive or negative 1/3. And then positive or negative 2 divided by positive or negative 3, which would be positive or negative 2/3. And then we move on to our last factor of 6, which was 6. Positive negative 1 divided by positive negative 6, which would be positive or negative 1/6. Then positive negative 2 divided by positive negative 6 would be positive or negative 1/3, which we already have. So these are all our possible factors of our function. Now for part B, we need to determine which of these factors, which of these possible rational roots are actual factors of our function. Let's start with positive 1. We pretty much can do it by trial and error. Start with positive 1, write down our coefficients. 6, 7, negative 12, negative 3, and 2. Bring down our 6. 6 times 1 is 6. 7 plus 6 is 13. 13 times 1 is 13. Negative 12 plus 13 is 1. 1 times 1 is 1. Negative 3 plus 1 is negative 2. That should say positive 1, not negative 1. Negative 2 times positive 1 would be negative 2. 2 plus negative 2 gives you 0. So that tells you that x equals 1 is a 0, which means x minus 1 is a factor. And what we get when we divide our original quartic function by x minus 1 would be x to the 3rd plus 13 x squared plus x and then minus 2. Now that cubic function, that's 6x to the third plus 13x squared plus x minus 2. Let's check some of those other zeros to find what the other factors are of that. So if we write down our factors, or our coefficients, 6, 13, 1, and negative 2, of our new polynomial, the 6x to the third. Let's check another one of those roots, say negative 2. See if negative 2... Let's see if negative 2 is a root. Bring down your 6. 6 times negative 2 is negative 12. 13 plus negative 12 would be 1. 1 times negative 2 is negative 2. 1 plus negative 2 is negative 1. Negative 1 times negative 2 is positive 2. Negative 2 plus 2 is 0. So now we have 6x squared plus x minus 1. So that tells you that x plus 2 is a factor. Alright, what we have so far is that x minus 1 times x plus 2 times 6x squared plus x minus 1 is what we have so far. Let's see if we can factor this 6x squared plus x minus 1 down. See, now let's go ahead and factor this quadratic down, 6x squared plus x minus 1. Alright, since we have a quadratic, we can use synthetic division to figure out some of those other numbers or possible zeros. Or we could just use the other ways to factor quadratic that we learned earlier. I'm going to go ahead and just factor this by grouping. 6 times 1 is 6. So I'm going to give you the factors of 6 that subtract to give you 1. The factors of 6 that subtract to give you 1 are 3 and 2. So that'd be 6x squared and then plus 3x and then minus 2x. And then minus 1. 6x squared plus 3x. Now if we want to group those terms together, we could factor 3x out of both of those, so that would leave us with 2x plus 1. Then for these last two terms, if we factor out a minus 1, we're left with 2x plus 1. So those, if we want to factor those by grouping, that would be 2x plus 1 times 3x minus 1. So that tells you that our last two zeros are negative 1/2, which was one of our original possible rational zeros, and also positive 1/3. So our original function, f of x, can be rewritten as x minus 1 times x plus 2 times 2x plus 1 and then times 3x minus 1. I ran out of room to write, or else this 3x minus 1 would be on the end. Alright, so if you have a function of degree n, meaning if it's a quadratic, cubic, or whatever, it's going to have at most that, whatever the highest exponent is, it's going to have at most that many distinct zeros. So like if you have a quadratic, it's going to have at most 2 distinct zeros or solutions. If it's a cubic, the highest exponent is 3, so it would have at most 3 distinct zeros. So here's a two-part example. It says find a function f defined by a polynomial of degree 3 that satisfies the given conditions. Part A, it says it has zeros at negative 1, 2, and 4, and f of 1 is equal to 3. So if it has zeros at negative 1, 2, and 4, then you know that your function f is equal to some number a, some leading coefficient, we don't know what it is yet, times. If it has a 0 at negative 1, then x plus 1 is a factor. And if it has a 0 at positive 2, then x minus 2 is a factor. And if it has a 0 at positive 4, then x minus 4 is a factor. Now, if f of 1 is 3, then that means 3 is equal to a times we plug in 1, then 1 plus, then instead of x plus 1, it'd be 1 plus 1, which is 2. And then instead of x minus 2, it'd be 1 minus 2, which is negative 1. And instead of x minus 4, it'd be 1 minus 4, which is negative 3. So it'd be 3 is equal to 2 times negative 1, which is negative 2, times negative 3 is positive 6. So 6a, which means your leading coefficient is just 1/2. So your function is equal to 1/2 times x plus 1 times x minus 2 times x minus 4. Or if you want to FOIL those three factors together, then distribute the 1/2. That would give you 1/2 x to the third minus 5/2 x squared plus x minus 4. We got this last equation, this last function here, by FOILing these three together. If you were to FOIL these three together, then multiply the 1/2 in, this is what you'd get. So for part B, negative 2 is a 0 of multiplicity 3. What that means is, let's go over what the negative 2 is a 0 means. That means x plus 2 is a factor, so some function is equal to some coefficient a times x plus 2. Now this multiplicity 3 means that this x plus 2 appears as a factor 3 times. That's what it means by multiplicity 3, is that you multiply x plus 2 by itself 3 times. So this is equal to a times some leading coefficient a times x plus 2 raised to the third. Now, one of our conditions is that f of negative 1 is equal to 4. So that means if we want to plug in those values, 4 is equal to a times, instead of x plus 2, it would be negative 1 plus 2 to the third, which would be negative 1 plus 2 is 1, raised to the third is 1, so 4 is equal to 1 times a, or just a. Which means f of x is equal to 4 times x plus 2 raised to the third power. Now this next thing that we're about to talk about is what we refer to as the conjugate zeros theorem. What it means is, if a conjugate, or if a complex number, a plus bi, is a 0, then its conjugate, which would be the same thing but you change the sign in front of the imaginary part, then the conjugate is also a 0. Alright, here's an example. Find all other zeros if x equals negative I is a 0 of this function, x to the fourth plus 5x squared plus 4. Alright, if x equals negative I is a 0, then that means x plus I is a factor. And both of these imply that x equals positive I is also a 0 by the conjugate zeros theorem, or that x minus I is a factor. So instead of dividing that quartic function, the x to the fourth plus 5x squared plus 4 by negative I, another way to think about this would be if you FOILed these together, x plus I times x minus I, if you were to FOIL these, you'd have x squared minus xi, then plus xi, then minus I squared. Those would cancel out. I squared is negative 1, so minus negative 1 mean you'd have x squared plus 1. So what you can do is take that quartic that x to the fourth plus 5x squared, that should be plus 0x to the third plus 5x squared plus 0x plus 4 divided by, we said we had x squared plus 1. Since it's just x squared plus 1, that'd be 0x plus 1. Remember, any missing x terms, just put 0 in front of them. It'll help you from getting confused. So now you multiply x squared by x squared to get x to the fourth. X squared times 0x would be 0x to the third. Then x squared times 1 would be positive x squared. Subtract all of that. You have 5x squared minus x squared would be 4x squared plus 0x and then plus 4. Now you multiply x squared by 4 to get 4x squared. 4x squared times 0x would be 0x. Now 4 times 1 would be plus 4. You notice we're subtracting the same thing from itself, so everything cancels out and we're left with 0. So our original quartic function, x to the fourth plus 5x squared plus 4 is equal to x squared plus 1 times x squared plus 4. So this is, remember, x squared plus 1 is equal to x plus I times x minus I times x squared plus 4. So if we want to find the zeros, x squared plus 4 equals 0, which means x squared is equal to negative 4, which means if you take the square root of both sides, x is equal to positive or negative 2i. That means x is equal to 2i, or x is equal to negative 2i. So as factors, that would be x minus 2i. And for x equals negative 2i, as a factor, that would be x plus 2i. So, if we want to rewrite our factors in red up here at the top, that would give us x plus I times x minus I times x plus 2i times x minus 2i.